In this video, we will be looking at exceptions in Java. Before we talk about the content, reminder, there's no class on Thursday, March the 9th. And our tutor and TA will be there during the lecture. So if you have questions about the content covered in this video, or you have questions about like the PSA 8, you can go there and ask. Okay. So let's look at exceptions. What is an exception? Exceptions that are basically runtime errors. As most of us have the experience, like a null pointer exception or array index out of bounds. Basically, those are when your code begin to run, you experience this error. And what Java allows us to do is to say, let's take care of those execution errors. So if you experience error during the execution of the code, there is a way for your code to either gracefully degrade, which means your code will stop running but not in a violent crash, or you may say, let's take care of it so my code can keep running. And that is what we'll talk about today. In this video, we will be looking at several clicker questions. So if we are looking at those questions, I'll usually pause a little bit. You can pause the video and think about what your solution might be before continue to kind of get the answer from the video. Okay. So the first exercise is more about the justifications of why we need to handle errors during the execution. If you look at this method called readIt, what we are trying to do is we are trying to read all the content from a file given as an argument in here into a string, and then we'll return this string. So that's why we have a return type. But when we try to read from a file, there are many unexpected things that may happen. So you may have this valid file method, supposedly if we have written it, and this method is going to return true if the file name is good, while else it's going to return false. So if this valid file name returns false, not valid will be true. So basically inside this if, we are trying to say if the file is invalid, what are we supposed to do? Given A, B, C, D, E, which one do you think is the right answer? Alright, so think about the answer, and now I will give out we'll look at all three of them. First one is print out an error message, which makes sense, right? You should let the user know something is wrong with the file. And what's more important is what would you do next, right? So for one thing, we probably don't want to continue anymore, because if you don't have a way to force the user to give you a right file, then if you continue to process the file, you're going to experience like a null pointer exception or something. So we want to stop. B and C both allow us to stop. Which one seems a little bit better? B, return a null. Basically, we return an empty string because your file is bad, so I'll return a null string, which makes sense. How about C? I'll just terminate, like system.exit. That is okay. But comparing with choice B, I would say probably if I'm writing this code, I'll be looking at A and B. So return null instead of just let my entire program terminate. For example, if I'm trying to read in a file in Word, so in Microsoft Word you click open and you are trying to open the file, but you encounter a bad file. Should the entire Word program crash because of this? The answer is most likely not. That's why we say error message and also just return null would be a good choice. Okay. So how do we take care of exceptions in here? We already seen it before, right? So if you look at this line, we're trying to create a scanner, and when you try to link a source file, which is basically a file object, this is a file object, right? So if you try to link a file object into a scanner, you may see an exception. So this line will say it is possible that you may encounter a runtime error, and this runtime error is IO exception. And what we have been doing, right, is throws IO exception. this throws basically means not my problem. If this method read it, experience this IO exception, the method will throw it back to the caller. So the caller will throw, the caller will basically take care of this IO exception. So whoever calls read it is supposed to take care of this IO exception. You may say, well, what if the caller doesn't take care of it? The caller then have to throw again to its caller. Super caller, you can call this super caller. Sooner or later, you're going to go to main, and that's where your code crash. Right? So this IO exception can be thrown at multiple layers until in the end, it reach main and the entire code will just terminate. So this is what we have been doing. It's basically to say it is not my problem, right? Throw it to my caller, and my caller can keep throw it. Another way to be more graceful is to say, let me try to take care of it in here. If you look at this try catch block, it is trying to say, let's try this statement. In other words, this statement might give you an exception. So there is a risk that this line, which will link a file object to a creator, to a scanner, that will give you the exception. Okay. So the catch in here is, if indeed you see a problem in this try clause, the catch will try to handle this exception. So this is kind of handle exception. What we did is we just print out this error message and then return null. So if you experience an IO exception, catch will be executed, and basically this statement will terminate the call to read it, right? The question is, what if I don't experience any exception? The answer would be, if try block doesn't throw any exception, then catch will be skipped. You will continue execution after the try catch block. So basically, catch is like a safety, right? If there is an exception, take care of it, and then continue. So the idea is, after catch, if you don't have this return null, what do you think will happen? So if the try and catch is the same, what if I don't have this return null in here? If I comment it out, what do you think will happen in here? A, B, C. So think about it. You can pause the video. So let's look at the answer. So if you comment out this return null, basically if there is a problem, if indeed there is a bad file name, what's going to happen is try will throw an exception. If there is an exception, and in fact it's going to be an IO exception, so if there is an exception, catch will be executed. You will print out this error message, and now what? Right? So do we continue or do we do something else? The answer is you will continue after catch, because by default the assumption is catch will take care of all potential problems. Your code can continue to execute normally. Okay, so if you return, if you comment out this return null, what's going to happen is this file, although it is bad, you are still trying to read from this file. So this will give you a null pointer exception. Right, so this is what's going to happen. So the answer would be A. Okay, so if you don't terminate the method call and you continue it, and your catch didn't take care of the problem, you may see a problem down the line. Okay, so this exercise really tells us that try and catch block, you will execute after catch with or without the exception. So if you have an exception, you will execute catch, then continue. If there is no exception, you will skip catch and continue after catch. Okay. So another question we have is, well, since if you don't have return null in here, and this code crash anyway because of the null pointer exception in here, right? Why does Java even allow you to compile this code, because this code is guaranteed to fail if you don't have this return null in there, right? So you are not really taking care of the potential danger of having a bad file name. So which one of the three choices you think is the correct answer? Okay, you can pause the video now. Let's look at the answer. The reason why Java even allow us to compile, although we have a risk of having a null pointer exception, is because null pointer exception and the IO exception that scanner might throw, there are two different kinds of errors. So the answer in here is because null pointer exception, it is unchecked. In other words, the compiler doesn't force you to take care of null pointer exception. The compiler allows your code to experience something like this. Okay. So if you look at the hierarchy of exceptions in here, everything starts from object. From object, you have a throwable, right? From throwable is basically the parent of two major classes. One is called error. Error, in fact, they are very, very serious problems. So the idea is you should never try to handle error. If your program experiences an error, you should let it crash. You should let it crash. Okay. The other branch is exception. So in this exception class, you have three kinds of exceptions. First kind is called a runtime exception. The other kind is IO exception, and you can create your own exceptions too, as indicated in the book. So the difference between runtime exception and IO exception is IO exception belongs to checked exceptions. In other words, the compiler will force you to say, if part of a code might throw an IO exception, you must take care of it by either throw it to a caller or you use a try-catch block to take care of it. Runtime exceptions, they are unchecked. In other words, compiler won't force you to do it. You may see like divide by zero errors or array index out of bound, null pointer exception. You can try to take care of them, but in general, if you experience them, usually means there's a bug in your program. So the recommendation is you shouldn't try to use try-catch block to capture unchecked exceptions. If you have those exceptions, probably you have a bug in your code. Instead of trying to fix this exception using try-catch, you should try to fix that bug that actually caused the exception. Okay, so this is kind of the difference between unchecked and checked. And this is basically the slide that just explained what I just explained in the previous slide.